Hey there, space enthusiasts! Welcome back to the channel, where we dive deep into the mysteries of our universe. In today's video, we're going to talk about something truly mind-blowing. The James Webb Space Telescope has just detected something gigantic colliding with Neptune. That's right, a colossal cosmic event has unfolded before our eyes, and we're here to break it all down. What does this mean for Neptune, our solar system, and future space exploration? Stick around, because we're about to dive into this epic event. Let's get started. The James Webb Space Telescope, JWST, is one of the most advanced observatories ever built, revolutionizing how we view the universe. Launched in December 2021, JWST is designed to observe distant galaxies, stars, and planets in unparalleled detail. Its powerful infrared sensors allow it to peer through cosmic dust and gas, revealing mysteries that have been hidden from human eyes for millennia. But perhaps the most exciting part, JWST has given us unprecedented insight into our own solar system. And now it's detected something gigantic that just collided with Neptune, a gas giant we've long studied but never witnessed in such an extraordinary event. So what exactly did JWST capture? The telescope recorded a massive object, likely a comet or asteroid, slamming into Neptune's atmosphere. This is no small event. We're talking about an impact that could have released more energy than multiple nuclear bombs combined. Neptune, known for its icy winds and stormy atmosphere, may now be experiencing even more turbulence due to this collision. The question on everyone's mind: what will this mean for the planet's structure, its atmosphere, and the larger solar system dynamics? We'll explore that next. Collisions of this magnitude can drastically affect a planet's atmosphere. Neptune, with its swirling clouds of hydrogen, helium, and methane, could see significant changes in its weather patterns. Imagine even more violent storms than those already recorded. The impact could also spark new heat waves, pushing temperatures to extremes we've never seen before on the distant planet. Additionally, the debris from this collision might form temporary rings or create disturbances in Neptune's magnetic field. These changes could last for years, giving scientists valuable data to study planetary evolution and celestial mechanics. Now, you may be wondering, why did this collision occur in the first place? Space is filled with countless objects, asteroids, comets, and even rogue planets that travel at high speeds. Sometimes, their paths intersect with planets, resulting in these massive collisions. In Neptune's case, it's possible that a long-period comet or a space rock from the Kuiper belt ventured too close and was pulled in by the planet's gravitational field. These types of events may seem rare, but they're a crucial part of the solar system's natural evolution. Each impact teaches us something new about how planetary bodies interact and change over time. This collision opens up exciting possibilities for future research. With JWST's powerful sensors, scientists can now track the aftermath of this event in real time. What happens next could reveal important details about Neptune's core, its atmosphere, and how such impacts can affect other gas giants like Uranus, or even exoplanets beyond our solar system. Future space missions may focus more on observing these giant planets and their environments. And who knows, this could lead to groundbreaking discoveries about the formation of planetary systems, or even how life might exist in these harsh environments. The Kuiper belt is a vast region of icy bodies beyond Neptune, filled with objects ranging from small comets to dwarf planets like Pluto. It's possible that the object that collided with Neptune originated from this region. The Kuiper belt is essentially the solar system's frozen outer frontier, and it holds many mysteries yet to be uncovered. This recent impact could bring new attention to the Kuiper belt, prompting further investigation. Could more objects be on a collision course with other planets? And what does this tell us about the gravitational interactions happening on the fringes of our solar system? Imagine an object the size of a small city hurtling through space at tens of thousands of miles per hour, then smashing into a gas giant like Neptune. The energy released by such an impact is almost incomprehensible. We're talking about a force equivalent to thousands of nuclear explosions. The resulting shockwave could have rippled across Neptune's atmosphere, creating seismic waves that may take weeks or even months to dissipate. This event will likely give scientists an unprecedented opportunity to study how planets react to such immense forces and how their atmospheres absorb and distribute the energy from impacts. Neptune has 14 known moons, with Triton being the largest and most fascinating. Triton orbits Neptune in the opposite direction of the planet's rotation, a phenomenon called retrograde orbit. This strange behavior has long puzzled astronomers, and now the recent collision could add more intrigue. Could the gravitational shock from the impact affect Triton or the other moons? If the object was large enough, it's possible that the debris or gravitational disturbances could cause slight shifts in the orbits of these moons, altering their long-term trajectories and potentially causing ripple effects throughout the system. When an object collides with a planet, the resulting impact can eject debris into space. In the case of Neptune, chunks of ice, rock, and gas may now be scattered throughout the surrounding region. This debris could become a new hazard, potentially leading to future collisions with other moons or planets. It's a reminder that our solar system is an ever-changing, dynamic place where cosmic events can trigger chain reactions. This impact might set off a series of smaller collisions that could take years or even decades to fully unfold, reshaping Neptune's environment. This collision is a once-in-a-lifetime opportunity for scientists. While impacts happen across the universe all the time, they're rarely observed in real time with the precision and technology we have today. Thanks to the JWST, astronomers can gather high-quality data on Neptune's atmospheric response, the trajectory of the object, and the aftermath of the impact. It's moments like these that can lead to groundbreaking discoveries, possibly reshaping our understanding of planetary science and the forces that govern our solar system. Neptune is already known for having some of the most violent storms in the solar system, with winds that can reach speeds of up to 12 miles per hour. But what happens when an object slams into this turbulent atmosphere? It's possible that the energy released by the impact could spark new storms or intensify existing ones. We could witness storms of unprecedented scale and power, and these weather systems could last for years, providing scientists with a front-row seat to some of the most extreme meteorological phenomena in the solar system. Throughout history, we've seen similar collisions in our solar system. One of the most famous was the impact of comet Shoemaker-Levy 9 with Jupiter in 1994, which left scars on the gas giant's atmosphere for months. Like the Jupiter event, Neptune's collision will likely leave lasting imprints that could be visible for a long time. By comparing these two events, scientists can gain a deeper understanding of how gas giants respond to external forces, and they can begin to draw parallels between planetary environments across the solar system. What does a collision on Neptune have to do with planets outside our solar system? A lot, actually. Gas giants like Neptune are common throughout the universe, and many exoplanets share similar characteristics. By studying how Neptune responds to this collision, scientists can make predictions about how exoplanets might behave under similar conditions. This could also inform future missions aimed at exploring these distant worlds, helping scientists identify exoplanets that may have experienced similar cosmic events. Did you know that Neptune has faint rings? They aren't as well known or as bright as Saturn's, but Neptune's rings are made of dust and ice particles. The collision might have sent shockwaves through these rings, causing disruptions or even adding more material to them. This is another fascinating aspect for astronomers to watch. If the impact has altered Neptune's rings in any significant way, it could give us new insights into the formation and evolution of planetary ring systems. How exactly did JWST spot this collision? The telescope's advanced infrared sensors are key to detecting thermal signatures and energy changes in distant objects. When a massive collision occurs, it releases heat and energy that can be captured by the JWST. Scientists then analyze this data to determine the size, speed, and composition of the impacting object. It's a complex process, but one that allows us to study events that are happening millions, even billions, of miles away with incredible detail. Gravitational forces play a significant role in the occurrence of planetary collisions. Neptune, being a massive gas giant, has a powerful gravitational pull that can draw in objects like comets and asteroids from far-off regions. This is likely what happened here. The object was pulled in by Neptune's gravity, accelerating as it approached the planet until it finally collided. By studying how gravity influences these events, scientists can predict where and when future collisions might occur, potentially giving us the chance to observe more cosmic events up close. The object that collided with Neptune may have broken apart upon impact, but fragments of it could still be floating in Neptune's atmosphere or in space. These fragments could provide valuable information about the composition of comets or asteroids in our solar system. By analyzing the debris, scientists can learn more about the materials that make up these objects and their potential origins. It's like piecing together a cosmic puzzle. Every bit of data brings us closer to understanding the bigger picture. One question that's often raised after a massive impact is whether the collision could alter a planet's orbit. In Neptune's case, the object was likely too small to cause any significant change in its orbit around the Sun. However, smaller impacts like this can still cause minute shifts in a planet's rotation or gravitational field. These changes are difficult to detect, but with the advanced technology we have today, scientists may be able to pick up on subtle variations that could tell us more about Neptune's long-term stability. This event highlights the importance of planetary protection, both for Neptune and for Earth. While Neptune is far from us, similar collisions could happen closer to home. Studying these events can help scientists develop strategies for detecting and potentially deflecting objects that might be on a collision course with Earth. In the future, we may need to rely on these insights to protect our planet from hazardous space debris or asteroids. The JWST has already proven itself as a game changer in space exploration, and this event is just the beginning. As scientists continue to analyze the data from the Neptune collision, we can expect more exciting discoveries from the telescope. Whether it's finding new planets, observing distant galaxies, or tracking more cosmic events like this one, the JWST is opening a new era of exploration. So, what will the telescope uncover next? Only time will tell, but one thing's for sure, the future of space exploration is brighter than ever. Planetary collisions are rare, but not entirely unheard of in our solar system. Most planets, including Earth, have been hit by large objects in their past, shaping their development. However, the frequency of these collisions has significantly decreased since the early days of the solar system. This is because many of the larger objects have already been absorbed into planets or moons over time. So, while a collision of this magnitude is uncommon today, it's a powerful reminder that our solar system is still an active and ever-evolving place, with the occasional dramatic event like this one shaping its history. Although Neptune itself is far too cold and hostile to support life as we know it, the planet's moons, particularly Triton, have long intrigued scientists. Some researchers speculate that Triton, which has geysers and an underground ocean, could potentially harbor microbial life. Could this impact have disturbed Triton's icy surface, or even triggered activity within its subsurface ocean? These are the types of questions scientists will be eager to explore in the aftermath of the collision. The event could give us valuable new data on Triton and bring us one step closer to understanding whether life could exist on these distant, icy moons. Neptune is famous for its incredibly dynamic atmosphere, marked by strong winds and massive storms, including its famous Great Dark Spot, a storm system similar to Jupiter's Great Red Spot. The collision could potentially alter these weather patterns, either dissipating existing storms or triggering new ones. If the object's impact created a significant shockwave, it may have disturbed the delicate balance of Neptune's atmosphere, causing unexpected changes. Observing these shifts over time could give scientists a rare look at how planetary atmospheres respond to sudden external forces. The success of the James Webb Space Telescope is paving the way for even more advanced telescopes in the future. Projects like the Nancy Grace Roman Space Telescope and others in development promise to give us even greater clarity when observing cosmic events like this Neptune collision. These future telescopes will push the boundaries of what we can see, potentially enabling us to observe planetary collisions in even more detail or capture other incredible cosmic phenomena. The technological advancements in space observation are ushering in a golden age of discovery. One key question scientists will be exploring is how long the effects of the collision will remain visible on Neptune. In the case of the Shoemaker-Levy 9 impact on Jupiter, the scars it left in the atmosphere were visible for months. We could see something similar on Neptune, where the impact zone might remain observable for an extended period. Over time, we'll be able to track how the planet's atmosphere absorbs and heals from the event. This ongoing observation will allow us to learn more about the resilience of planetary atmospheres in the wake of such dramatic events. While most of the immediate effects will be observed on Neptune's surface or atmosphere, it's worth considering whether the impact could have influenced the planet's internal structure. Gas giants like Neptune have thick atmospheres but also hidden cores. Depending on the size of the object and the depth of its impact, it's possible that this collision could have caused internal shifts within the planet's core or mantle. If that's the case, we may be able to detect subtle changes in the planet's gravitational field or magnetic activity, offering new clues about the inner workings of gas giants. Events like this collision remind us of how dynamic our solar system truly is. For planetary scientists, this is an invaluable case study that can help refine existing models of planetary evolution, atmospheric dynamics, and gravitational interactions. These real-time observations allow scientists to test theories and make predictions about other planets, both within and beyond our solar system. The knowledge gained from this single event could have far-reaching implications, influencing how we approach the study of exoplanets and deep space exploration in the coming decades. Although Neptune is located on the outer edge of our solar system, it's important to remember that all planets are interconnected through gravitational forces. While the immediate effects of the collision are localized to Neptune, there is a possibility that gravitational shifts from this event could subtly affect nearby bodies, including Uranus, or even distant objects in the Kuiper belt. Scientists will be paying close attention to whether this event causes any detectable shifts in the orbits or behaviors of other solar system objects. The impact has the potential to reveal new information about Neptune's composition, both on the surface and in its atmosphere. When an object collides with a planet, it can kick up material from deep within the planet's atmosphere, or even expose previously hidden layers. By analyzing the chemical signatures left behind in the aftermath of the impact, scientists can learn more about what Neptune is made of and how its unique environment operates. This could lead to new discoveries about the planet's formation and evolution over billions of years. Where did the object that collided with Neptune come from? That's one of the key questions scientists will be working to answer. If the object originated in the Kuiper belt, or even further out in the Oort cloud, this collision could give us important clues about the population and behavior of objects in these distant regions of the solar system. Understanding the origin and trajectory of this object could also help scientists predict future collisions and better understand the distribution of materials in our cosmic neighborhood. While this collision was a rare event, it's possible that we may witness more planetary impacts in the future. The JWST and other advanced telescopes allow us to monitor the skies like never before, increasing the chances of detecting incoming objects. As we continue to observe the outer solar system, we may be able to predict when and where the next major collision will happen. These events, while destructive, offer scientists unparalleled opportunities to study planetary environments and the forces that shape them. One fascinating aspect of massive planetary collisions is their potential to create new elements or compounds. The intense heat and pressure generated during an impact can trigger chemical reactions that may not occur under normal conditions. If the collision on Neptune was powerful enough, it's possible that new elements or compounds were formed in the planet's atmosphere. Studying these reactions could provide insights into the types of chemical processes that occur during high-energy events and how they contribute to planetary evolution. Neptune is a resilient planet, but it will still take time for the effects of the collision to fully dissipate. The shockwaves and atmospheric disturbances caused by the impact could last for months or even years, depending on the size and energy of the event. Over time, Neptune's atmosphere will likely stabilize, but in the meantime, we'll have a unique window into the planet's recovery process. Observing how Neptune bounces back from this impact will help scientists better understand how planets handle such extreme events. Neptune's magnetic field is one of the most unusual in the solar system, tilted at an extreme angle relative to its axis of rotation. This collision might give scientists a chance to study how Neptune's magnetic field responds to external forces. If the impact caused any disturbances in the planet's magnetosphere, it could reveal new information about how the magnetic fields of gas giants function and interact with their surrounding environments. This could be crucial for future studies of planetary magnetism across the universe. If we can detect this collision on Neptune, could we also observe impacts on exoplanets orbiting distant stars? The technology that enabled JWST to capture this event could be used in the future to monitor other solar systems for similar collisions. Detecting these signals from afar would give scientists a wealth of information about the dynamics of planetary systems beyond our own, opening new doors for exoplanet research and potentially even the search for extraterrestrial life. Studying a major cosmic event like this one requires the collaboration of scientists and observatories from all over the world. Data collected from JWST is shared with researchers across multiple disciplines, from astronomers to physicists. This level of international collaboration is crucial for interpreting the complex data produced by an event of this magnitude.
Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.